Okay. All right. Hello, everybody. Sorry I'm not here today. I'm down at the track, down at the football field, helping the seniors get ready for graduation. So I apologize, but I'll be back Monday morning. So if you guys get lost or need help, please come find me. Okay. So hopefully this is easy. Okay. So today, what we want to talk about is this. Today's date, June 10th. Okay. 2022. We want to talk about solving triangles using the law of cosines. Law of cosines is different. The law of cosines is different, okay? We have the law of sines, now we get the law of cosines. So, what if you don't have a pair of opposites? If you don't have a pair of opposites, you have to use the law of cosines, okay? If you don't have a pair of opposites, you're going to have to use the law of cosines, okay? So, what you do, though, what you might have is side angle side. So what you do know is side angle side. We call it SAS, okay? Side angle side. And again, if I get going too fast, just ask the substitute to pause the video so you can get caught up, okay? I'm going to try and pace it well, okay? So here's what I know. Taking a look at this example, I don't have a pair of opposites. I don't at all. But I have a side angle side. Okay, the angle is in the middle. It's in between the two sides. And that's what we have here is the side angle side. The angle I know is in between the two sides. Okay, so law of cosines deals with an angle, theta, like 52. And then these two sides. Now these two sides are the adjacent sides. They're both adjacent. So I've got an adjacent side here and an adjacent side here. And on this opposite side, it's not a hypotenuse, it's not a right triangle, it's just an opposite side. So we're going to use the law of cosines to find the opposite side. Okay? Here's how it works. It's going to be a long formula. It's not difficult, it's just long. So the formula says this. It is opposite squared equals the adjacent, one of the adjacent squared, plus the other adjacent squared. It doesn't matter which one. The other adjacent squared minus 2, and that 2 is part of the formula, times the adjacent side times the other adjacent side times the cosine of theta. All right? So what we're going to do, we're going to put all of these numbers into the calculator, which in this case, the numbers in example 1 would be like the 12, the 14, and the angle 52. We're going to put all those in the calculator, okay? So when we get done with all of this, it's still opposite squares. So this takes 2 steps. So your other steps. So the next thing you do is you get this answer and you take the square root of this answer. So it's going to take 2 steps, okay? All right. Let's use this big long formula to get the answer to this one, okay? Hopefully I'm not going too fast. If you need it paused so you can catch up, that'd be great. Okay, let's take a look at it. Find length of AC. AC is here, which is also could be called side B, okay? I like opposites because that means the nice thing about opposites is that I can use the law of sines, but there's no opposites. You don't have opposites. 52, that's a B. It looks like a 6, but that's a B, okay? That's a B. That we do not have a pair of opposites at all. but what I do have is side, angle, side. I have a side, I have an angle, and a side. So I can't use the law of sines, but I can use the law of cosines. Well, all right, let's figure it out. Let's use the formula. Here it is. Opposite squared. That's b. So these are my adjacents. 12 is. 14 is my other adjacent. And side b is my opposite side from the angle I'm working with. Okay, that's the angle I'm working with. That's theta. So my formula, opposite squared. So I'm going to go little b squared equals my adjacent squared. Well, either one. How about 12 squared plus the other adjacent, which is 14 squared, minus 2 times my adjacent, which is my 12, times my other adjacent, which is 14, times the cosine of my angle, which is 52 degrees. All right, it's kind of a long formula, but that's okay because I have a calculator. So I'm going to put all of this into my all of that into my calculator. Put all of that into my calculator. Like this. Okay. Check my mode. Make sure my mode's in degree mode. Radians are for my Algebra 2 kids, so I'm in degree mode. And here we go. I'm typing in. I can ignore this for a second. 12 squared plus 14 squared. Subtract 2 times 12 times 14 times cosine of 52. Okay? That's all my calculus. See, 12 squared plus 14 squared minus 2 times 12 times 14 times cosine of 52. So I push enter, and I get this answer. 133.137, blah, blah, blah. So by the way, there's no way that could be that side. B cannot be that big. If that's 12, that's 14, that can't be that big because it's b squared. And remember, I said there's 2 steps to this. So the second thing I'm going to do is solve for b. I'm just going to take the square root of both sides, square root of both sides, square root of that answer, and then I get about 11.54, maybe 11.54. So b about 11.54. There you go. All right. Now, awesome. Let me put that back in here. So now we've got that side, which is great because now if we want to use the easier formula, which is the law of sines, I think the law of sines is the easier one, we have a pair of opposites. So now if I want to solve the triangle all the way through, once you have a pair of opposites, you can use the law of sines. So do you have a pair of opposites? Pair of opposites? Yes. I've got the 52 degree angle and its opposite side, 11.4. So now I can finish up the rest of this by using the law of sines. Makes it a little bit easier. So what I do know is either the 14 or the 12. I can either find angle A or angle C. It doesn't really matter. I'm just going to pick angle C because I have the 12 and the C. Okay, so if I have my opposites, then I don't need the law of cosines. I can use the law of sines, which is what we did yesterday. So I know I'm going to use the sine of theta 1 over opposite 1 equals sine of theta 2 over opposite 2. That's the law of sines. Don't worry, on Monday we're going to review all of our laws. We'll get them all on one piece of paper. We will. So then, do we have a pair of opposites? Yes. There they are. Let's use the law of sines to find angle C. So, okay, angle C. So I'm going to set it up in this form. I'm going to go sine of angle C over its opposite, which is 12, equals the sine of 52 over its opposite, which is my 11.54. Okay, now to solve for this rest of this, okay, I'm going to go ahead and just multiply both sides. I'm going to solve for C, so multiply by 12 both sides. I will have sine C is equal to 12 times the sine of 52 over 11.54. Okay, I'm going to put that on my calculator. So put that on my calculator. And I'm going to go 12 times sine of 52 divided by 11.54. And I get a decimal, but that's right because I'm looking for the angle. Remember, I don't know the angle. So I have to take the sine inverse of that answer, of that decimal, right? So it'll go sine inverse real. I'll write it down. Look for the sine inverse of my, I don't know, what is it, 0.8194, blah, 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 blah. So sine inverse, because you're looking for the angle. Always, when you find the angle, inverse the blue button of my decimal, my point, blah, blah, blah. And I get about a 55-degree angle, okay? So angle C then is about 55 degrees. Okay, let's go back to my triangle. Angle C is 55 degrees. And then finally, we can finish this triangle up pretty easily because then to find angle A, well, let's see, angle A, we know how many degrees are in a triangle, 180. So to find angle A, I'm just going to go 180 degrees minus the sum of these two, 52 plus 55 degrees, and I'll get the value of angle A. Okay, clear. I'm going to go 180 minus my 52 plus my 55, and I get an answer about 73 degrees. All right, there it is. So we're not going to do the back side. We're going to talk about that on Monday. We're going to stop there. That's the lesson. Hopefully you guys can do this, work together. I'll be back on Monday. We can take a look and see how you did, okay? All right, have a great weekend. See you at graduation.